So how do we read a one-way ANOVA table? So this is an example of the one that we're actually going to calculate here in just a little bit at the end of the video. And what we see here is that in our between, we're going to look at this p-value, and we see our p-value is less than 0.05, which is our critical value. So that means we reject the null hypothesis. The null hypothesis, again, remember, there is no significant difference between the groups. So we reject that, which means that one or more groups is showing a significant difference, which means further testing is required. That is the big one here. We don't know which treatment is different. We look at this degrees of freedom. We see that we have 3 degrees of freedom, which means that we have 4 groups. So that means at least one of those 4 groups has a significant effect, a significant difference than the others. So the further testing we can do, it's often called post hoc testing. We would do in a similar example as that previous one, where there is a significant effect of one of the treatments. Using QE Suite, the QE Suite ANOVA one-way, QE.ANOVA one-way, actually provides you with quite a few things. It provides you with some descriptive statistics, an ANOVA table, and a confidence interval that can be used to evaluate significance. So that's not the only one. We have many post hoc methods that perform grouping on the treatments to show which groups are significantly different. So confidence interval is one way, but there's multiple. You have a Fisher least significant difference, Duncan's multiple range test, and a Tukey pairwise comparison. And those are all included in QE Suite. So let's take a look at our confidence interval comparison here. So this is for that same data. We know that there's a significant difference. We just have to figure out where that is. So we're using a 95% confidence interval. Again, this was generated with the QE.ANOVA one-way. So we have our ANOVA results and we have our confidence interval all returned in one easy function. So here we have group 1, 2, 3, and 4. We have our means. So you'll see here, just looking at the means, group 1 and group 4 seem to be pretty different. So let's see if our confidence intervals overlap. So we see group 1, the low is 5.57. And then if we look at the highs of the others, 4.03, 4.43, and 2.23, there is no overlap between the low of group 1 and any of the others, which means that group 1 is significantly different using the 95% confidence interval. We look at group 2, and we see that these two here overlap between that 2.37 and 4.03. So there's no significant difference here at the 95% confidence interval. If we look at this bottom one here, group 4, we see, well, we're not going to be intersecting anything on the low end, so let's look at the high, 2.23, and that is greater than 1.97. Therefore, group 4 is not significantly different from group 2. However, it is from group 1 and group 3. So we used the 95% confidence interval table, and we found that group 1 was significantly different than other groups, and group 4 was significantly different from some of the other groups too, not all of them. So what we want to do is we do want to use the post hoc methods, other post hoc methods, because we find something different. The Tukey pairwise, Fisher LSD, and Duncan multiple range all agree group 1 is significantly different, but group 2, 3, and 4 have been grouped together and are not significantly different. Now, if you remember from that previous slide, I'll go back to it here, there is a significant difference between group 3 and group 4. It's pretty close. You've got 0.14, and if you look, that's like 10% of a standard deviation. And if we come over here, these other methods all agree. So what we're probably going to want to do is, using all of our methods, say, yep, group 1 is significantly different, but group 2, 3, and 4 are not significantly different. And that's why we give you so many different methods, because you really do want to be trying as much as possible. That way you really do rely on as much information as possible. Okay, so what happens if we have no significant effect of our treatment? What if the p-value for the between-group variation is greater than our alpha value? Well, then we fail to reject the null hypothesis, and so there is no significant difference between the groups at our alpha level. and therefore we have no justification for further analysis. So that's really what we would say, is we say we have no justification for further analysis. We won't do any post hoc testing because now we're assuming that there's no significant difference.